Good morning and welcome to the 29th annual exhibit of hydrogen and fuel cell technology here at the Hannover Fair. I am going to shorten my abbreviation because time is of the essence. Those of you who watched the elevator pitches yesterday encountered Yi Young, Vice President of Sales at Green Power. Today he's back to talk about how to address the challenge of unstable renewable electricity. Please welcome with me Yi Young.
Guten Tag. Good afternoon, ladies and gentlemen. I'm Yang from Green Power, a manufacturer of power supply units and a system integrator of green hydrogen production. It's my great honor here to discuss with you this topic, how to address the challenge of unstable renewable electricity. First, please allow me to introduce a little bit about our company. Green Power is located in Zhongshan City, Hubei province in China, where is also my hometown, right in the middle of China. And we have R&D centers in Beijing, in Chengdu, Sichuan province, and Foshan, Guangdong province. I have to remind you to remember this province called Yunnan province because I will mention it in the later slides. We have accumulated more than 20 years of experience in design, manufacturing, and service of electrolytic power systems. And before COVID, more than 80% of our revenue came from overseas, which means we are quite familiar with the international standards, CAE for Europe, UL for America, and CSA for Canada, etc. And we have a very fast-growing team. More than 40% of our employees are engineers. Among them, 10 are doctors, including our chairman, who is also a leading professor in Sichuan University, and 10 doctors and more than 20 masters. So far, we have a production capacity of 5 gigawatt PSU each year, which means we can support 5 gigafactory of electrolyzers at the same time. And the good news is we will double our production capacity by the end of this year. Power supply is not rocket science. However, depending on the source of electricity, different kinds of power supply will be applied. Typically, the electricity generated from solar and wind will be transmitted through the grid, which is also the simplest scenario. An AC/DC rectifier can handle this. Nowadays, developers prefer to build the power plant, the hydrogen plants, and even the ammonia plants near each other. Then we can connect the solar power or wind power to the electrolyzer directly. Then a DC-DC converter or AC/DC rectifier without transformer will be applied. In a more complex scenario, when using multi-energy, for example, combining solar and grid, or even combining solar, wind, and grid together, an integrated power system will be applied. We all know renewable energy are located in different places in the world, which means the power supply unit has to be in compliance with different local standards. For example, for the European market, we provide products with CE certification. And in most cases, the developer only has limited space for the power supply unit. So the size of the PSU matters. Last year, we delivered more than 130 projects larger than 5 megawatt, and near 30 of them are containerized, including the largest one in Saudi Arabia. Well, that is why I mentioned the Yunnan province previously. This slide shows a multi-energy smart grid project. The electricity generated from solar and wind, backed by the grid, drives the electrolyzer to split water into hydrogen and oxygen. The hydrogen is stored in the solid-state hydrogen storage unit. The hydrogen then can be fed to the refueling station, the emergency generator, or feed back to the grid via fuel cells. The system just connected to the grid a few days ago in Yunnan province in China. Unfortunately, before the battle between Mac and Windows, I prepared a video for you, but you have to watch it at our stand, E39. I only have 10 minutes, so I have to stop here. If you are interested in the project I mentioned or any product offerings we have, please visit us at E39. And I have to say, life is just like a box of chocolate. We didn't get our poster on time, so I have to draw my pictures on the wall, and you will see it at our stand. And today, I'm not able to play the video, so who knows what happened. Thank you for your attention. I'm Yang from Green Power.
Almost forgot my microphone. We do have time for some questions here. Are there any questions from the audience? Yes.
My name is Martin from WEC in Brazil. You showed some different rectifier solution with SCR and IGBT. Can you explain a little the difference and benefits in between the technologies?
Well, I only have 5 minutes, so we can talk at our booth, but I just want to expand a little bit. SCR was invented in 1960, so it's a very mature technology, and IGBT is becoming popular. There is no bad choice, only suitable choice for application. Normally, when you provide a PSU for a large power project, when you ask for a higher efficiency and high power factor, low THDI, and low current ripple. This time, if it is larger than 5 megawatt, we would recommend SCR. But if you provide a PSU for PAM and just connect to wind power or solar power, must provide a fast response, maybe IGBT is more suitable. So there's no right or wrong solution. We have to sit together to see how large is your project, how many electrolyzer are using. Probably you are using a combination of alkaline and the PAM. Then we can design a customized power supply system for you. Thank you for your question.
Any other questions? Still a minute left. I'm missing it. Who's got the hand up here? Someone over here? Oh, way over in this corner. Thank you.
Oh.
Hello? Okay, can you hear me? Yeah. This is Iker from Ingetim. We also manufacture power converters. And I just wanted to ask you, why do you propose SCR rectifiers when considering a unitary power factors? I mean, why do you consider for large-scale plants SCR rectifiers when we have requirements of unitary power factors?
Do you mean for a large project, SCR couldn't provide a high power factor or can provide a
I mean that SCR rectifiers inject harmonics into the grid, so you need filters. Also, SCR rectifiers inject reactive power. If you add the reactive power generated by the rectifier and the filter, then you need a huge amount of reactive power to compensate so as to reach the unitary power factor. So
Yeah,
that's a trade-off.
Yeah, understood. That's why I said we should have coffee and discuss it. The answer is no bad or good choice. We can use SCR to achieve a higher power factor. Yeah, there are many ways to achieve the target. So we have to use actual equipment to do that. So yeah, we can find out a solution to achieve the specific parameter. And I just want to add what we are looking for. We are looking for a total high efficient system, which means to help you save money. So what is efficiency? Efficiency is how much electricity generated will be used to produce hydrogen. So that is you are looking for, I believe, as an owner. The power factor, you just achieve the target required by the grid or the local authority. After you achieve the target, maybe I should say this, even you are doing better, it seems you will not get further reward for this. So that's why we have to sit together to see what's your target and what we can offer to you. Thank you.
Okay. Yeah, that was an interesting talk. Of course, the details are better discussed at the booth. Your booth number is
E39.
E39. Yeah, I did.
Sima Han joins, please.
Yeah, I'd recommend you join Young there. Yeah, thank you. Ye Yong, Vice President of Sales at Green Power, for your discussion.
Thank you.
Wonderful talk to you. Thank you. We'll be back.